Okay, so for today's topic, we are going to talk about matrices. Okay, so what exactly is a matrix? Okay, so a matrix is basically a rectangular array of numbers. Okay, and the numbers are what we call elements. Okay, and then when we talk about matrix, right, we must be very clear of rows and columns. Okay, so let's say, for example, the first matrix over here. Okay, this is what we call row, right? So the horizontal one is what we call row. So this is row number 1 and this is row number 2. So in this array, there are 2 rows and also columns where it is the vertical. Okay, so this is column 1 and this is column 2. Okay, so in this case, this has 2 rows and 2 columns. Okay, and then let's look at the second matrix. Okay, it has 1 row, 2 row, 3 rows. Okay, and it only has 1 single column. Okay, so this is a rectangular array with 3 rows and 1 column. And then for the next one over here, we have 1 row, okay, and 3 columns. Okay. Okay, so it's very important to identify what is a row and a column. A row is basically a horizontal line and a column is a vertical line. Okay. So here we are going to describe some terms and also different types of matrices. Okay, so just now we talk about row and columns, right? Okay, so when we talk about the order of a matrix, order means the number of rows multiplied by the number of columns the matrix contains. Okay, so for example, if we have this matrix over here, okay, so like I said just now, this is 1 row, this is 2 rows. Okay, so this is a 2 row by 1 column matrix. Okay, so we always write the order as row by column. Okay, so this is a 2 by 1 matrix. And then similarly, this is a 2 row, okay, by 2 column matrix. Okay, so this is a 2 by 2 matrix. Okay, then again, 1 row and 3 columns. Okay, so 1 by 3 matrix. Okay, so that's what we define as the order of a matrix. Okay, then just now, right, you have seen examples like this and this. Okay, so this is basically a 3 by 1 matrix, right? Okay, this is what we will call a column matrix, and this is what we will call a row matrix. Okay, simply because this contains only 1 column and this contains 1 row. Okay, so this is how we define a row matrix. A row matrix has exactly 1 row. Okay, so its order should be 1 times n. Okay, because it's always in the form of row times column. Okay, so if we see horizontally like that, right, numbers arranged in this way, this is what we call a row matrix. Okay, a 1 by something matrix. Okay, then for column matrix is the reverse. So when you see like a vertical arrangement, 1 single vertical arrangement of numbers, this is what we call a column matrix. Okay, because it has exactly 1 column and the order will then be m times 1. Okay, so row times column. So the column will be 1 column. Okay, so same thing for this. You have 1 column, 1 column. Okay, so this is a 2 by 1 matrix and 3 by 1 matrix. Okay, so just something to take note of. Your column matrix usually will be used as a second matrix. Okay, which we will see in subsequent examples later on. Okay, how we would utilize column matrix. Okay, now comes this part over here, a square matrix. Okay, like what we know about square, right? Square should have equal sides, correct? So when we talk about square matrix, basically it should have the same number of rows and columns. Okay, so the same number of entries in column. Okay, so if we talk about a square matrix, it should have, say, number of rows and columns. So that means your order would be n times n matrix, okay? Where n is just some number. Okay, some positive integer. Okay, so let's say, for example, this is a matrix. So whenever you see two brackets, right, this is not a number, okay? This is a matrix. Okay, so whenever you see two brackets, this is represented as a matrix. So this is actually a 1 by 1 matrix. Okay, then when you look at this second example, this is a 2 by 2 matrix. Okay, so it's also a square matrix. Then for the third example, it is a 3 by 3 matrix. Okay, so also a square matrix. Okay, so this will be very important when we define other types of matrix later on. Okay, this next type is what we call the zero matrix or the null matrix. Okay, as the name suggests, a zero matrix basically has all the elements inside the matrix equal to 0. Okay, so basically it is denoted by this bolded 0. So it's not just a number 0, okay? It means a matrix containing all entries or elements that are 0. Okay, so this doesn't have to be a square matrix per se, it's just all the entries are 0. Okay, so some examples over here. So just a side note, this is a 1 by 1, this is a 2 by 2, and this is a 1 by 3 matrix. Okay. Okay, next, this is an important one, identity matrix. Okay, so first thing about identity matrix that we have to know of is it must be a square matrix. Okay, so that's the first condition. Okay, in which all the elements in the leading diagonal, okay, leading diagonal means diagonal from left to right. Okay, and these entries, the leading diagonal entries, should be equal to 1. Okay, so you see over here and over here. Okay, while the rest of the elements should be equal to 0. Okay, and then we usually denote it by a bolded I. Okay, so there's also another term which we call the diagonal matrix. Okay, so this can be also considered as a diagonal matrix. Okay, where the diagonal elements equals to 1. Okay, so for diagonal matrix, it is defined as a square matrix also. Okay, first condition, such that all the entries outside of the leading diagonal would be 0. Okay, so the diagonal entries need not be 1 in this case. Okay, it's just all the entries outside of the diagonal should be 0. Okay, so first thing must be a square matrix. Okay, where all elements outside of leading diagonal are 0. Okay, so an example could be something like that. Okay, maybe 3, 0, 0, 0, 5, 0, 0, 0, 2. Okay, so now you see the diagonal entries are not 0, but then the other entries outside of the leading diagonal are 0s. Okay, so this is a diagonal matrix. Okay, an identity matrix is considered a diagonal matrix. Okay, last part over here, where we talk about equal matrices. Okay, equal matrices, first of all, they should be of the same order and their corresponding elements should also be equal. Okay, so they should be exactly the same. Okay, so if we say a matrix A equals to B, so let's say for example this, it means this entry in row 1, column 1 should be equals to this should be equals to this equals to this, and this entry in row 2, column 2 should be equals to this. Okay, they must be exactly the same. That's what we mean by corresponding elements are equal. Okay, then of course they have to be in the same order so that you can compare one by one, right? Okay, so in this case, we know the value of x should be equals to 1, and this equals to this. So that means your y should be equals to 10. Okay? Okay, so one key thing to take note of, like I said just now, for equal matrices, they need to be of the same order first, correct? So if you see something like that, yes, their entries seem similar, right? The elements inside are similar. But this is a 1 by 2 matrix, while this is a 2 by 1 matrix. Okay, so they have different orders. Okay, so they are not the same matrix. Okay, so you can say this matrix is not equals to the other matrix. Okay. Okay, we will pause here for now. So this is what we have for an introduction of all the different types of matrices.